what are the different stages or steps which you adopt typically to make sure that you can deliver the model end to end. So there are different practices been done in industry for a long time. So I'm going to talk about what are the different methodologies or execution methodologies been adopted, how we evolved, and with my own experience in the last 23 years, I have built my own framework or execution methodology, I would say, which I practice to deliver ML models successfully, starting from end to end. So that's what we're going to talk about today. Safe harbor, what I'm going to talk about. The initial slides are from different corporate, the product companies like SAS and IBM and SAP. And the last version is my own version, which I learned it through practices. And safe harbor, it's my own understanding. That's what I just want to clarify before I move on. The agenda for today is, as I mentioned, I'm going to talk about machine learning development, execution methodologies, or development lifecycle as per se. There are different steps you need to take when you want to develop machine learning models. And as I mentioned, I'm going to talk about some of the earlier versions of methodologies which were introduced by the analytical product companies like SAS and IBM and SAP, and then how it has evolved and how we matured enough now. What is the kind of execution methodology we have on which we work and deliver ML models? So I'm going to start with SAS. SAS, of course, I worked with SAS 15 years before. So they had an initial framework called the SEMA methodology. So SEMA was the initial method to, was a simple guidance for people to, to work on ML model or to deliver some data science projects or data mining projects. That time, that's how it's been called. So SEMA methodology is what I'm going to give a quick brief on what is SEMA. And then there was a little maturity. People have understood, industries have started coming together and they wanted to have a single framework to deliver data mining projects or data science projects. That's called as CRISP-DM, which is the cross-industry standard practice for data mining. And there were 5 companies came together: NCR, Daimler, Virchar, and Insurance, ISL, and Teradata. They came together. They had a lot of brainstorming, and then they made a methodology, execution methodology, and it's a mere guidance on if you want to deliver a data mining project or data science, or nowadays you call as AML projects, what are the different steps you need to do, adopt it and do it. So that's a CRISP-DM. I would say that's a kind of little matured, this initial step of maturity, we have seen it. And then ML in a box, that is SAP. SAP normally offers ML in a box, which is the hardware plus the software or the product. So they had a guidelines on how do you, do ML model if you want to do it by the steps. And the final is the execution methodology is almost the combination of all the 3, what you see. SAS and IBM adopted CRISP-DM for SPSS, and then SAP had ML in a box. The execution methodology, the last bullet point, is primarily what I have practiced throughout my career, and that's what I'm going to talk about today. Now, my request, if you have any questions, please do put it in chat, or if you feel like you need to stop me and talk. I'm not sure of this etiquettes, but any questions, please do put it in the chat so that last 15 minutes we can discuss about that. Now, moving on to SEMA methodology, that's SAS. SAS is an analytical tool, if you're not aware of it. So they were a little pioneer on, suggesting if you want to deliver any data science project, these are the minimum steps to be taken. And they called it a SEMA methodology. SEMA is nothing but what you can see in the left side, which is sample, explore, modify, model, and assess. So that's SEMA. The basic assumption of using this methodology, which SAS was prescribing, is the data is in a ready shape to be, to be modeled. So this is not talking about, your initial works on understanding the business, understanding the problem which business wanted to solve, what data is required, all those things. This is basically the SEMA came out from SAS with the purpose that you're going to use SAS primarily to deliver an ML model. If this is the place you need to start, this assumes that the data is in a ready shape for to be used. It starts with sampling, assuming you have a data ready for modeling. You start with sampling. So initially, 15, 20 years before, when we started building models, we used to always think about building samples because we don't have a huge infrastructures per se. And then if you have a huge data, it's very important that you take a sample of it, which is the right representation of the population. so that you don't kill the resources and you don't run for 20 hours or 2 days or 3 days to build the model. So we do a lot of sampling, but the decision is now also you need to take a decision: do you need a sample or not? So initial decision of sampling, we used to have a lot of sampling methodologies we used to use based on the requirement of the business. We have simple random sampling, cluster random sampling, stratified random samples, snowball sampling. There are 10 plus sampling methodologies we used to choose based on the business requirements. So that's the first part of your first step in your execution methodology. So you start taking a decision on whether you're going to take a sample or not. Once you take a sample, you need to explore the data. It is very, very important. Exploring the data will give you confidence on the data on which you're going to work it. You're also going to assess whether that serves the purpose of what we are trying to do. It will also help you, doing all the modifying model, the further steps. The exploration give you guidance on how to modify, what models you need to apply, and what assess metrics you need to choose. So the explore by far is very important. Normally nowadays you call it as stats, summary stats, and call as EDA, exploratory data analysis. So there are multiple ways to do EDA, exploratory data analysis. You explore the data by using stats, which is using summary stats. If it is a continuous data, I look at whether it's a distribution. If it is discrete data, I look at the frequencies. That's a typical univariate analysis. So exploration, EDA, typically in ML models, if you have a target supervised models, you will do a bivariate univariate analysis where you will do analysis on each and every features on which you're going to work on. And then you will also do a bivariate analysis, which is X versus the Y. You try to understand, is there a relation between the input towards the outputs? And that you do by two methods. One, either do it by summary stats, that's purely using statistical methods. And then you'll also do by data visualization, which is using graphical methods. So by both the methods, the core purpose of Explore is to understand the data on which you're going to work on. And if there are missing values, there are anomalies, if there are outliers, how do you handle it? So it will give you all the guidance. It's also called as data audit in some tools. And there are a lot of terms when used. Ideally, it is nothing but just explore the data, make sure you understand the data on which you're going to build the model. The right-hand side of Explore is typically the unsupervised side of it. If you don't have a target, if you do a clustering, you're trying to group the data based on the similarities, based on the homogeneities. That's also part of explorations, because you're not in any way building a model. There's no target variable on which you're going to work on it. So you just have a group of people or a group of products or a group of stores. You try to group them by some homogeneities. That's the clustering, and then probably you might do some profiling also. So that's all part of explorations. You also do association analysis, famously known as market basket analysis, right? So these are all some of the activities are part of Explore. So after you sample, you explore the data, make sure you understand the data, perfectly. Then based on whatever you explored, you will now start doing modifications. Or you might create new variables. That's a variable creations. You might select variables. You might be given with a huge amount of, like, say, 200, 300, or 500 features or variables. All variables may not be useful for representing or explaining why the target, right? So it's very important that you build a model which is the best fit, we call it as. You choose the right variables, or you reduce the variables in such a way that you build a simple model, but with the high performance, performing model. So a part of modifications, you either do variable selection, you do variable creations. We also do a lot of works now, but that's not part of SEMA methodology at that moment. It's not explicitly been mentioned, like missing value imputation. And then right side, you see data transformations. A missing value imputation is, if the features are having missing values, then you need to impute it, because we had the basic models like linear regression, logistic, all those models, I would say the simultaneous equation-based models. If there are a lot of missing values, model doesn't perform well. Let's say you have 100 records. There's one particular feature has got 90% of the data is missing, then the 90% of the records are ignored by those algorithms. So it is very important that you impute those features before even we expose the data to modeling. And the data transformation, there are a lot of algorithms assumes data to be normally distributed if it is continuous data. The basic models like linear regression models or regression models, I would say, they assume that the data, continuous data, to be normal. And if you don't find a normality, it is skewed, or there's a heavy kurtosis, then probably you need to do a lot of transformations. That's one type of transformations you do it. So these are all the modifications. So you explored it, you understood the problems in the data, and then you modified the data to best suit to get models. Now, once you finish modify your model, your data is ready to get modeled. Now you whatever the ED you did based on that, now you know what kind of models you need to do it. You may start with a very simple structural models. If it is a continuous data, the target is continuous, you might start with regressions. If it is categorical, you might get into classifications, you might do forecasting. There are a lot of approaches, analytical approaches, you will do it. But this modeling, as per methodology, this is a place you would choose multiple models, you will build multiple models to predict Y. It might start with the simple models like regression models, to classification models, to unstructured models like decision trees, and then to any nonlinear models like neural network. Any combination of algorithms you can try out to make sure what is the best model to predict your Y. And then now that you build multiple models, part of modeling phase, you need to assess the models. So you need to choose the best model, and you see whether the best model complies to the minimum accuracy or minimum performance you have been asserted for. So the model assessment is a place where you choose a model metric based on the business requirements or the stats requirements. And using that model matrices, you would compare the multiple models what you built, and then you choose the best model. And then if the best model, you will assess it with a testing data. So when we do a sampling, we will also do data partition, where you would partition the data into training and testing. Normally we do training and testing now, but otherwise we'll do training, validation, and testing. The testing data is the holdout sample or the holdout data on which the model was not explored. The algorithm was not explored. So you build a model in the training data and take the model and test it in the test data. The model is doing good. You can take it for production. If it is not, then you go back to the sample and then you need to redo everything, retrain everything. So that's the cycle which SEMA was being suggested. SAS was suggesting as part of SEMA. This is a very basic way of doing methodology, but that's the starting point, I would say, where people started assessing that there's a sequence by which you can start build ML models. Now the second is CRISP-DM methodology. As I mentioned, CRISP is cross-industry standard practice for data mining. And I was showing in the agenda slide, there were 5 different companies came together, did a lot of brainstorming, and then they finalized that this is the sequence of steps we need to do for any data mining or data science projects to be done. Now, if you look at these 6 steps, this is called a 6 phases of CRISP methodology. The center is the data. Again, data is the core of any data science or ML models we built it, right? Now, if you look at all the 6 steps, apart from the first and last, the business understanding and deployment, the rest of the 4 will look very similar to SEMA, right? The previous one what you have seen, except sample, the first one. So the data understanding is equivalent to explore there, and then data preparation is equivalent to the modify there, and modeling is equivalent to model there, and evaluation is equivalent to assess there. So the bottom 4 is equivalent to SEMA without yes. This CRISP-DM methodology where they added 2 more steps, which is completing end-to-end cycle. As I was mentioning in SEMA, the basic assumption is you have the data ready, which means you have understood the problem. What is the data to address that problem, and the data is ready from where you start SEMA. Here they completed the cycle, completely. I would say this is the the thorough or complete cycle for any data science methodology. Starts with business understanding. You need to understand the pain areas in business for which you're going to build the model, and the business problem. So it's very important to state the business problem and business understanding, because business understanding will help us do a lot of data preparation. But you would be in a position to choose the right data, and you would be in a position to create new variables if you have a very clear business understanding. So that's the place it starts. The CRISP-DM methodology suggests that you should start having a business understanding. Once you have the business understanding, then you get into data understanding specific to the problem what you're trying to solve it. And this is you can see the directions. It's a bi-directional. You may go back and forth between data, business understanding and data understanding to make sure your data is, you could be able to build the perfect data or the near perfect data, which can solve your machine learning problem or which solve your business problem. Once your data understanding is clear, you will start preparing your data. That's a place, that's a part of where you will understand, you explore the data, and then you modify the data in such a way that the data is ready for modeling. And again, you see it's bi-directional. You will build the model and you look at the performance of the model, you come back, you create new features. So the data preparation and modeling can happen back and forth. You might prepare a data first, and then you expose to modeling, see how model performs. The model is not good, you might come back and again, add new features or delete some features, and you might do that again, like back and forth. And then you have a final model being built, and then that model is taken for evaluation. So you have set up models. Models are taken for evaluation, as I mentioned in the previous slide. Part of evaluation, you would test the model in a holdout sample which was not exposed during training, so that you can understand whether the model will perform in future in consistent way. So this evaluation will give us a confidence that the model is inconsistent. It's the best fit for to use. And once you have the final model, evaluation is good. If evaluation is not good, you can see the blue line again going back to business understanding, which means you're going to repeat the cycle now to make sure that you have the best model goes before deployment. You get the best model before deployment. So assuming you did the evaluation and you got the best model in place, then you go for deployment. Deployment is a place where you productionize the model. That's the place it goes for scheduling. We do a lot of automation. So in future, you build the model, you put it in deployment in production, so that in future, when the future data comes in, it automatically flows to the model and the prediction happens, it gets stored. It's also been directed to the dashboard or insights for the consumption. The whole pipeline of the model being consumed is been taken care. Also, model monitoring, model operations, everything is taken care for the deployment. So this Crisp PDM is the first place I would say at the complete view of end-to-end machine learning development lifecycle, starting from business understanding to data understanding, and data preparation, modeling, evaluation, and deployment. So this is a 6 steps, which predominantly at a 30,000 feet level covers what we normally practice now also. Now, the third is SAP. So what you have seen is SEMA, which is a SaaS offered, and then Crisp PDM, which is a conglomeration with a lot of 5 different companies came together and they prepared and they advised industry to practice. And this is ML in a box. That's the uniqueness of SAP. Normally, that's how SAP offers HANA. And here, if you look at the top 6 bars, it is very similar to Crisp PDM. Business understanding, data understanding. Of course, this is the same like Crisp PDM. But here, they were in a position to detail out a part of business understanding, what do you do? Part of data understanding, what do you do? So they were in a position to expand it, decipher it, to give you the different detailed steps which you adopt part of each of this 6 steps. So business understanding, there are 4 steps were advised by SAP. First, part of business understanding, first you need to determine the business objective. It's very important to understand what is this ML model is going to solve in business. There should be some business pain areas or some aspirations the business is having for which you are trying to build an ML model, and that's going to solve this purpose. So that's determine business objectives. Assess the situation. Assess the situation is you try to understand the current scenario of the same. You might have some current rudiment model, for example. So that's we call as the current as-is models or current as-is situations. So you need to know what is being currently practiced, so that becomes the baseline. And when I build a model, I can go and compare to see whether my model is really performing better than the current process. So assess the current situation and for the same problem. Now, you determine the data mining goals now. The difference between 1.3 and 1.1. So 1.1 is determining business objective. That's the place we start. But then the business objective, most of the time, it could be qualitative by nature, which means it is not in a quantifiable state. For example, let's say a retail company, they have a business objective. They have a business problem where they are giving you as they want to assess whether their customer is happy with them or not. Now, this is a business statement. The business problem you are trying to solve it, whether my customer is happy with my product or not. Now, if you just look at this is absolutely qualitative by nature, right? Now, if I want to solve it by ML or if I want to solve it by data, I need to convert this qualitative objective into a quantifiable one so that I can really measure, collect data and measure it. So the business objective, if it is qualitative by nature, then the data mining goal is a place where I'll convert that one into a quantitative goals so that I can build data, I can measure it, and, I can perform it. So the difference between 1.1 and 1.3 is a qualitative objective is converted to a quantifiable statistical questions, I would say. Okay. So once you get a clarity on, and it could be possible that one business objective, which is qualitative by nature, might be derived as in 3 or 4 statistical data mining goals. Now, for example, as an example, I was saying, the business wanted to know whether my customer is happy with my product or not. Now, the happy is the underlying word. I need to split that one into multiple quantifiable targets or goals. I need to understand what is the, happy about my product, which means what is the basic qualities of products by which you're measuring the happiness of the customers. Now, if the product is a retail product, are we talking about usability of the product? Are we talking about tangibility of the product, or the aesthetic of the product, or package of the product? So, if you're going to ask these questions of these 4 data, these 4 product qualities been answered by client, by a customer, and if the customer is happy with all 4, I would say that the customer is overall happy with it. So now what I did, I converted the business objective, which is qualitative by nature, into a quantifiable statistical questions in the data mining. It could be multiples. Once you have statistical data mining goals, you will now produce a project plan of how to this is like a project charter, which you normally do for any projects, where you'll say, this is the questions to answer, this is the data I'm going to use, this is the team members, this is the timeline I'm going to take, and you have a project plan like a Gantt chart. Normally we do it in project methodology, in project management. You produce the project plan that will tell you how much time it's going to take, how many people are going to work, what is the expected output, what is the scope, what is out of scope, and everything. So that's the project plan. So these all 4 steps put together is what business understanding as a step is going to solve. Now the next step is on data understanding. Now you have the basic groundwork is been done. You are clear with what is the business problem, what is the statistical question you're going to solve. You have the project plan. Now you start looking into data understanding. You'll collect the initial data from whatever you plan, and then you'll describe the data, which is again, EDA. You do an exploratory data analysis, which is describe the data and then explore the data. Describe is you try to understand these are the input variables and these are the target. This is a grouping variable, there's an ID. So you describe the data. Once you describe the data, you'll now start exploring the data to understand, do we have the the right set of data? Is there any missing values? Is there any outliers? Is there any place where the data is not normal? So you do all explorations, you tabulate it, or you do the audit and keep it ready, because this will help you to the data preparation. That's the next step. And last is overall, like you verify data quality. There are basic data qualities, maybe typos, maybe missings, right? So these are very basic, verify the data qualities. And if at all there is a data quality issues, there are a lot of noises, there are a lot of typos, then probably you need to build rules or approaches to make sure you clean up the data. Now, once you clean up the data, the basic data is ready. Now you get in data preparation. Now you select the data. A lot of projects where data has to be selected, you may not be in a position to use the population as is. For example, the objective of the project is to understand or do some analysis on a particular location, or you are interested in doing a project on millennials, you are interested in doing a project on people above 50 years old. So these are all very specific segments on which you want to do a project. Then probably you need to select the data. You need to filter the right set of data on which you're going to work on it. Now, based on the data quality or audit and everything, you'll clean the data. Now you'll construct the data, and then you'll integrate it. Integrating is probably whatever you want to solve it. It might be available in 2-3 different tables in the sources. Probably you need to bring them together by different primary key or secondary, tertiary keys, and then you combine them, bring one unified data set, and then before formatting, so that the data is ready for getting modeled. And once you integrate and you get the unified data, you will start now formatting the data for the right fit. We call as ABT, which is typically analytics-based tables, which is you cleaned up the data, you kept the data ready for modeling. So once the 3.5 is done, the data is ready for modeling. We get into step 4, which is modeling. where you select the modeling technique. And, our modeling technique, as I was saying earlier, it might be a regression-based model, it might be classification model, it might be forecasting, whatever the type of models. Within that, there are different algorithms. You can adopt it, anything starting from a simple regression to XGBoost or even to deep learning models. Any modeling techniques and algorithms, you take a call on that. And then you generate the test design, which is like a data partition or test cases. You build test cases by which once the model has been built, you might go and test it. The simplest format is you have the data, you do a partition, do a testing and training, and then testing data in which you do a testing. There are places where we do a scenario-based testing also, where we build different case studies. What if this is the input? See what is the output it gives. We know explicitly by business process that if these are the inputs, this should be the outcome. Those kind of scenarios also could be tested to validate whether the model is up to standard to go to production. Do all that, it's just so this 4.2 is just generating the test designs, not really testing it. The testing happens typically in 4.4, which is assess the model. So you design what are the test cases, what is the test data on which you're going to test it, and then you will build the model now. The step 1 and 2 are typically design part of it. You will select the modeling techniques, you design the testing cases or the test data, and then now you build the models, and then you assess the models. You might have multiple different model metrics by which you want to compare it, let's say accuracy or AUC or misclassification or error terms. So there are different model metrics by which you compare multiple models what you built, and then you would compare to get the best model out. So that's how the assess model will work. Now, when you do an assessment, you get the final model. So end of the 4th step, modeling step, you get the best model out. That model is taken for evaluation. So you evaluate the results and then review the process by which you build these models. And if at all there is something you need to do it, after you review the process, you might need to enhance the model. You might need to add some more to groom the model better. Our model is not performing good to your requirements, then probably you need to have reconciliation again to see what is that you want to do again. So you determine the next steps. That's the evaluation piece of it. And the last part is again deployment. Deployment is you plan your deployment, which also is kind of at what schedule you want to run the model. Like, are you going to run it monthly? Are you going to run it weekly or daily or an hourly? Or even you might think or plan to run this model in real time. There are a lot of models runs in real time. So you need to plan it. Also, you plan the platform on which you want to run it. It also depends on the different platforms. You might need API call, you might need a dashboard. So all these things are planned for deployment. And as I mentioned earlier, ML ops, which is ML operations. It's very important that you need to plan the monitoring and maintenance of the models. So you need to continuously monitor the model for its performance. Once you build a model, it's not a silver bullet that it will be used throughout its lifetime. It so happened that in about 3 months' time or 6 months' time, the model performance might deteriorate. So we have something called a champion challenger recently. Nowadays we use where we parallelly develop a challenger model when the champion model, which is in production, which is in prediction mode, if the performance deteriorates, we override by challenger model, and then we again kind of redevelop the model. So that's on the model performance. We will also monitor the drifts. Drifts are like data drift or target drift, we call it as. Data drift is when we build a model using a training data, we have seen a set of data distribution. Let's say I've used age of a customer, and when I trained the model, the age group was around 18 to 30. That's a age group of customers where I trained it. Now, in future, if somebody with 40 years old, somebody with 60 years old comes, definitely model would not have realized it. That's the drawback of ML models. Of course, now we have the GenAI models, which can now do that, has a capability. But now, ML per se, if the model hasn't got exposed during training, any data, new data, it will definitely, the model accuracy will get a hit. So we also have a drift monitoring where if the data is drifting between what was being trained and what is the current, if suddenly there is a drift happens, then we get an alert system. So we can understand that we're getting a new data which was not exposed, so that we can take a call on whether we need to recalibrate the model or redevelop the model, etc. So that's all part of 6.2 plan monitoring and maintenance. And now that I started scoring, I started predicting, I produce the final reports that could be consumable by the business. The core purpose of why we did the model. It might be a report, it might be a dashboard, it could be any form, it might be an email communication. So the ML model could be exposed to different consumption layers. That's the last one. And finally, it will be the projects. Finally, you might take a call on whether this project is still serving the purpose, or is there a place where you need to go and sunset it, or you need to revise it, you need to add something. So all those decisions you might take in a frequent phase, maybe after every 6 months, after every 1 year, or there's a new completely whole gamut of data is coming in, or there's a new technology like you brought in Chennai, you want to revisit the ML model, what it's doing. So all these things you will do it as an end. And you might take a call here. The review project might resulted in, should we recalibrate the model? Should we redevelop the model? Or sometime you might need to sunset the model so that you can start looking into some other model for the same business objective to be solved, or the business objective is solved for a rare case, but it's quite possible that you built a model for a business problem which is valid only for a year time. Then probably you might need to sunset the model, and then you might look at some new projects or business objectives for which you're going to build it. So this is ML in a box by SAP. And now you would have understood from SEMA to CRISP-DM to ML in a box, there's more details being added to the machine learning approach. And this gives a little more clarity on what are the different macro steps you need to take it. Within that, what are the different detailed steps? This is a very good, guideline for anybody who's wanted to practice ML or want to venture into ML. These are the minimum steps to be taken. And let me tell you, not that every step to be maintained or to be adopted every time. It depends on as you grow, as you start practicing more and more, you would see that there are some steps you can combine it. There are some steps you might not even do it. For example, integrate data. For example, you might get the whole data, whatever you want to use, it might be in a single table. You might not even do it. Integration data or data quality has been done part of the data pipeline itself. In the primary data itself, all data quality has been done, and the data is certified already. You might not even doing verified data quality. So not that all steps are very mandate, but then it is important that you should take care of this. If it is already taken care somewhere else, probably you can skip it. But these are overall is what people typically adopt when they develop ML models. And the last is, I don't know that it's too visible or not, but pardon me if it is not too visible. From whatever we learned it using SAS or CRISP-DM or ML in a box by SAP, this is something which I derived about 15 years before, and I'm still adopting it. And I keep on groom this. And if you look at this top, I have it like the discovery phase, and then data ingestion phase, and then model development phase, insights delivery, and ongoing calibration. That's how I define execution method. Or there are 5 major steps by which you can work on it. If you're in a consulting framework, if you're in a consulting firm, now I'm currently in a captive system. It's a telecom company, but I worked with different consulting companies like Capgemini, ITC, L&T, etc. So there are 2 frameworks I see in this whole machine learning development lifecycle. The first 2 are consulting frameworks, which means the people who are going to do it, they need to have a blend of business understanding as well as the data understanding. So that's very important for the consulting framework. The first 2, where when they start understanding what is the business problem, what is the data rightly which will solve business problem, those people should have a domain flavor on which they're going to work it. For example, the problem is on banking. So if you don't know the banking nuances or the terminologies of the jargons, it's very difficult for you to really understand the data which is going to solve some particular problem. So this consulting framework is a flavor of people who have a business understanding, a domain understanding, and the data understanding. And then the delivery framework is kind of a pure data science work. So once you know exactly the data on which you're going to work it, the rest of the 8 steps are typically statistical or data science specific steps. That's how I say it. It is very similar to ML in a box or CRISP-DM. Nothing, there's not magics, but then there's more details being added based on the experience or based on the practice, what I've done. So if you look at the business problem identification, there's a place all the other approaches have started. I'm also starting the same one. But I started with the stakeholder meeting. That's the place you initiate some basic discussion with the stakeholders, and then you understand what is the problem they want to solve it. That's the place where you start, and then the stakeholder meeting, the outcome of that is the business objective. So you understand why this ML project is going to be done. So determine the business objective is similar to the other approaches. Now you understand the business scope to deliver. This scoping is very important. It's not that you're going to solve all the universal problems. There's a specific scope for which the model is going to be generated. There are in scopes, there are out of scopes also, which means those nuances are not going to be taken care by this model. Not that you built a model that could be applied everywhere and anywhere, right? Whatever you built it, it has to be, you have to be very clear on what is the scope and where this is going to be applied, right? So that is what happened. You build a model with some specific restricted scope, and you collected data also with the same perspective. But then people started applying in different places. They might come back and complain that, hey, my model is not working, and that's quite possible. So it's very important you clearly draft the in scope and the out of scope. And the last point is determine the statistical goals or questions. It's very similar like the previous one, as I discussed. The business objective could be qualitative in nature, and it is very important that you convert that one into statistical questions so that you can quantify the data and the measurement, and you can really compare to see whether the model really serves our purpose or not. So that is determining statistical goals and questions. That's the first step, business problem identification. Once you have converted, now you have the statistical questions which you want to answer. Now you start looking at the data which is going to solve each and every question which you drafted. So you understand the data requirements, you collect the initial data, explore the data, which is again the EDA, which is what you do. Now again, verify the data quality. Before you do anything on the data, it is very important to look at the data quality. And the data quality should be at par, it should be at the best, because otherwise, whatever the magic you do in modeling, and if junk in is a junk out, right? So if your data is not for the right purpose, the model, whatever you're going to do in the model, finally, you're not going to get anything out. It's junk in, junk out. So it's very important to look at the data quality, verify the data quality so that when you start preparing data, you can, do all the data imputation, data transformation, everything. The last point is target leakage check. It is very important to check. This target leakage is a very important problem. A lot of times what happens when you build a model, you have all the input data features, which is going to explain the target variable. You don't even realize that when you're trying to take it for scoring or predictions or production, whatever you call it as, those inputs are not available at that moment, right? It might be coming in future, tomorrow, but you are trying to predict today. So it's very important to use the inputs which are available beforehand for predicting some things, for predicting why. That's one simple example of target leakage. The other is you build an input which is similar, which is exactly representing the target. You have a target variable like a churn or a fraud or whatever target you want to predict it, or like number of days somebody is going to take to churn. That's a continuous data. And very similar, from that target, you built an input. You have recoded that and you are using it as an input. It's definitely a target leakage, which means that variable will exactly represent why, and that variable will not be available in future, because unless you don't know why, you can't derive that X. So that's all simple examples of what we call as target leakage. So it's very important to check the target leakage, make sure there's no target leakage so that your data is in the right status for getting built as a model. Now that's a consulting framework. The delivery framework is the place where you build the models. That starts with the hypothesis creation. You need to create hypothesis of the problems. A lot of times, hypothesis, as we all know, it's an assumptions. Business will have, on the process, they'll have a lot of assumptions. It's very important. If those business process assumptions are going to hamper or it's going to impact your model, it is very important that you create hypothesis and make sure you test it, right? So you create the hypothesis, and as I was mentioning on the early slides, there are algorithms where you need to, there are algorithms which has got their own assumptions as well. So you need to list down all assumptions, whether it's an assumption by business, which you need to validate it because that might hamper your modeling effort, or there are algorithms which has got their own intrinsic hypothesis. You need to list down all the hypotheses and you need to make sure you validate the hypothesis. And during validation, if you understand that the validation to be refined. You'll refine the hypothesis and you retest it again. So make sure all the hypothesis has been tested before even you jump into modeling. Now the original work of data preparation starts. You already did a data understanding. You know what's the data on which you're going to work it. You've did an audit on the data quality. You've checked for the target quality. Now you select the data. Again, it's similar to ML in a box. Every model has been built for a specific purpose. So whatever the population of data has been given to you, you need to go and select the data for which the model is going to be built in. So to select data, then you do a data partition. Data partition is basically, I think I was mentioning, you split the data into training, validation, and testing. Training is the data on which you're going to build the model. So the model will be trained on the training data. Validation is a set where you would refine the model. You will fine-tune the model to make it best, and then testing data where you will apply once, see whether the model performs to your minimum requirements. If it is yes, take it to production. Otherwise, you come back and on redo it. So that's the data partition, the purpose of data partition. Once you partition the data, you'll describe the data. That's the EDA. Different tools called, some tools called as a describe, some tools called as a data audit, etc. But into it, you are trying to understand the data and you're trying to understand what is the problem with the data. If at all there are anomalies, there are noises, there are outliers, imputation, missing values, you're going to, do all sort of audit on the data. If you find there are missing values, then you'll do imputation. Imputation is you're replacing the missing values with some logical values. And a lot of times the imputation could be anything from a very simple, like an imputing with an average value or the most frequent value to anything to a very highly modeled imputation. A lot of times the imputation is very important for us. Then we even take the variable, the input which is missing as a target and using other inputs as an input. We build a model and then we impute it. So for imputation itself, we even build an ML model and impute it. That's high end of imputing it. Last, there are algos, as I mentioned, assumes that the data is going to be normally distributed. If it is not, then you need to transform the data. Now, once you do, the data is ready. I think most of the things are I'm repeating it, but let me go a little quick. So the model build, once you have a data, right data, the analytics-based tables, now you can expose that into model build. You'll select the modeling techniques based on the type of target, based on the type of business objective or statistical questions you want to solve. You would select the right modeling techniques, and then you build various models. So within that modeling techniques, there are different algorithms you can use it. So you build various models, decide the model fit stats. As I was mentioning, you might choose that I have built multiple models. I'm going to look at accuracy. I'm going to look at error. I'm going to look at misclassification. I'm going to look at AUC, area under curve. So I choose the model fit statistics by which I'm going to compare the models, and I'm going to choose the best model. And once I do that, I validate the model and I test the model. So as I mentioned, validation is a place where you might groom the model, or you might refine the model or fine-tune the model, and then you test the model in the testing data. Validation is a place where you might expose the model multiple times from the data to make sure you groom the model and refine it. And the testing the model is a place where you test it once, and if it meets the requirements, you take it for productions. Otherwise, scrap or go back and recalibrate or redevelop it. That's how you're going to do it. I've added new ones. This is called as external factor identification. When you build a model, most of the time, the inputs what you use for building the model, it may not be sufficient. There may be opportunities where you do a lot of literature surveys before doing some works. You understand that if these data are there, this is the right explanation. This will exactly represent the target, but a lot of times you may not have, or the business or the process doesn't have it. There are variables which are macro by nature, macroeconomic variables, like in GDP, unemployment, they might have some impact to your model output also. So you need to identify the external factors, which is not part of your current model, but it might have an impact on your model. If those values are there, it is very good. So you might need to document it saying these are the external factors, and you might give an impact on, the report on how it's going to impact your models. We also do a lot of something called as temporal infidelity. For example, you build a model with set of features, and the impact of those features might increase as time progresses, or might decrease. And it might decrease and might get accelerated in a year time. It's very important. You should know that and document it so that the business or whomsoever is in a monitoring stage, they might be in a position to come back and redevelop it because they know that now there are a couple of features might get obsolete after some time. So it is very important that you do all those things and document it properly. So that's the factor identifications. Once you do that, now the model validation, evaluation, that is, you assess your model, evaluate the results, and then final model, which is the final model goes for scoring. We call it scoring, predictions, or production model, whatever you call it is. It's basically the final model is taken for production. That's the deployment. Determine next stage. As I was mentioning, this is optional stage. If you do a final model, if you evaluate the results, you're not convinced, you might need to redevelop or recalibrate. That's the next stages you have it at all. The defined visualization is the consumption layer. You are building a score. Let's say you are forecasting something. You are predicting whether somebody is going to be a fraud or not. You're predicting somebody is going to be a churn or not. You're giving a score. You're giving a probability. That should be put it in a fashion or a format so that business can start consuming it. So we need a consumption layer, maybe a dashboard, maybe a report, maybe an email communication. So you decide on the visualization, determine who is going to use it. There's an end user. Who is going to use our model? You need to decide on that and what platform they have. How do they communicate? How do they consume this? So we need to define the information delivery channel. That's the consumption layer, maybe a dashboard, maybe a report, whatever it is. And decide on the data load schedule. As I mentioned earlier, you might need to discuss with business to understand at what frequency data is going to come in so that you decide at what frequency the model should run. The data might come every month once, every week once, every day once, every hour once, or in real time. Based on that, you also decide at what time frequency you're going to schedule the model so that it's going to run during that time to solve a purpose. There are models which you need to run that in real time. If you don't run it, there's no purpose of that having a model. But there are models where model is eligible to run in real time, but the data comes in a frequency. Data comes every hour. Definitely, even if you run it in a real time, it doesn't going to change anything for an hour time. So you decide all those schedules based on the data load and how frequently business wanted to see the changes. And you decide on the alert management, if any. There are places where you start predicting something, and if it goes beyond a threshold or below a threshold, business might wanted an alert system to be done. Right? We also do for data validation. Sometimes there's a drift happen, as I was mentioning the previous slides. The data drift is happening, then probably as a data scientist, I want an alert to be sent to me. So these are all part of the data visualization. Same way, if there's in real time you're monitoring something, let's say a call center, the command center wanted to know suddenly there's a huge surge calls. Normally the calls are every hour, there are 100 calls comes in a particular hour, there's 1,000 calls. There should be an alert to be sent to them so that they can depute more agents or they can see how to route it. So, the command center can take a call and there's a sudden surge happens. So these are all some of the alert management systems you need to build so that, this could be proactive by nature. And the ninth step is deployment. You make the code as production ready code. When you develop it, you might have EDA, like discrete data, all those things, but that you don't need it for production ready code. You don't describe it. It's just to predict something. So you might clean up the code, make it production ready code, and then you decide the platform where it's going to be hosted. Now we have a lot of cloud platforms on which we are working currently. We are working on GCP, we are working on AWS. So decide the platform on which it's going to work it. Decide the schedule for running. So it will go in line with the previous box, like the decide on the data load. If the data load is real time, I can run the model in real time. If the data load is 1 hour, I can run the model in every 1 hour. Or even sometimes the data load is 1 hour, but business requirement is every week once. So even data load is 1 hour, I can run the model every week once. So that kind of decisions I take, decide the schedule for running. Now decide the metrics to report. What metrics you want to report on the consumption so that business wanted to use it. Those are the KPIs which business is more interested as an outcome from the model. Implement the model, that's the end of your deployment. And the maintenance, that's ML ops and machine learning operations, where I was talking about like data drift, target drift, model performance being continuously monitored. The champion challenger model. The champion model is a model which is used for predictions. Challenger model, with the new data, it continuously learns. So the challenger model is up to date with the new data, whereas champion is a model which is continuously predicting. At a particular point of time, maybe after 6 months, you see that champion model performance is deteriorating. So we can put a threshold saying if the model accuracy is less than 70%, that's a trigger. The moment the model accuracy comes less than 70%, the challenger can go and overwrite it because challenger learned the new data also. So it's background parallelly, challenger keeps on learning with the new data. And then whenever there's a champion is not performing, challenger can go and overwrite it. This structure also you can build it. We call this champion challenger model. And at some point of time, it might so happen that even you have a challenger, but it's still not performing well. You should take a call on whether we need to recalibrate the model or redevelop it. Recalibration is the same existing features of the inputs. You're trying to tune it or bin it or whatever you want to do it. But redevelop is you might completely scrap it or add new features and redevelop it again. And as I was saying in the previous slide, there could be a decision you might take, even saying you need to sunset the this model. You might decide on the criterions by which you're going to sunset the model, and you might go for a completely new model based on, as you were saying, could be temporal effect. This project, this business objective is only for 6 months. Then probably you need to sunset it, or whatever you're trying to do, recalibration or redevelop the model is not, improving beyond that. You need to completely change the way it's going to be built or it's going to be architected. Then probably you sunset this and start new. So that's how we do it. So this is a pretty simple framework. And as I said, not that all steps should be adopted for all models. It's just a guideline, not a silver bullet or a Bible. So based on your requirements, you can start, looking at what steps to be adopted, what is mandate steps. So this is just a framework or guideline for any machine learning model to be executed. Okay, so that's pretty much I have. Thank you very much. Utkarsh, if you have any questions, we can talk about it.
Yes, sir. Yes. First of all, a very good evening to all the participants. I Utkarsh Gaurav, host for today's industrial interaction session on machine learning development lifecycle execution methodology. Before going ahead with the Q&A, I would really like to thank Suresh sir for taking out the time and sharing his knowledge with the upcoming future data scientists, right? And today we are incredibly fortunate to have you as our guest speaker for unraveling the intricacies of the machine learning development life cycle with execution methodology. Your expertise is definitely valuable insights that will enrich our understanding in this cutting edge subject, sir. The, the process and the methodology shared will be really helpful for many attendees towards handling the industrial problem they will be facing not only in various competition and hackathon, but also during the career in the field of data science. So further, without any ado, let's start with the Q&A. So, sir, first question we have is that how is the data connected? Like a student wants to know that should they be learning different kind of tools which will to export the data? Like since when you start with the machine learning and machine learning model and train the data, the person has to export the data. So what are the tools one should look upon, learn in the upcoming future, or should have knowledge over to express?
Okay, perfect. Thanks for the question. So exploring data, is that the tools only for exploration or for model development? I'm guessing it is only exploration.
It is regarding the importing the data from the various APIs or various resources.
Yeah. So we might use the API directly, or we normally, as with my experience, is all SQLs. We still use it. There are a lot of cloud platforms. All the DBs, we normally use the SQLs. A bit of SQL knowledge is very essential for exporting any data to your Python platform or the analytics platform on which you're going to work at. If you're on a commercial tool like SAS or IBM, like in drag and drop tools, they will give you a provision. There will be nodes which you just need to put it and give the direction of the data where it is there. You can save your SQL knowledge there. It can that node can bring in data to your platform of the tool. So commercial tools, if you're lucky enough to work on commercial tools, you don't need to worry too much about it. It'll take care of it, sourcing it. If it is like in SAS offers anything from ETL Studio, that's also belongs to SAS, and then there's a SAS E-miner. So all the products bundled, to be offered, the data sourcing is very easy. But currently, we are working a lot of open source tools like Python or in other places. You might need a basic knowledge on SQL to source the data to your platform and then start developing it. So that's on the data exploration.
Right. Thank you, sir. That should answer the query. Next question we have is like, how important is the understanding of deep learning in ML? Like, what is the importance of algo models should one have in condition to industrial problems? Like, what are the importance algorithm or ML models should work upon or learn during the to handle the when they are into the proper industrial field?
Right. So let me break this into two. Understanding between ML, DL, and RL or reinforcement learning, that is separate with an ML algorithm. So it's like width and the breadth. So ML to DL to RL, like reinforcement learning, everything is a breadth. It's an evolve. You need to evolve it because ML typically has been used when you have a lot of structured data, like a numeric data. When you have a semi-structured data, you eventually get into NLP and other things. When you have unstructured data like audio, video, image, is only DL will do it because there are a lot of layers you need to work on it. So that's how the purpose grows. So it depends on the type of data, and we are also now testing DL for numerical data also. When there's a lot of non-linearities there, and we want neural net to answer it, we are testing it there as well. But ideally, this is a flow. It's a maturity as you go from ML to DL to RL. That's the horizontal. Now within ML or within DL, within RL, you have a lot of algos to work on. Like ML, you have linear logistic regression, your random forest, Bayesian tree, XGBoost. You have everything. Like DL, you have DNN, RNN, CNN, LSTM, all these things. So it is very important to understand. If you look at only ML, let me just talk about ML. The different algos have different purposes. Like if you want a structural equation base, you might stick with regression or logistic regression, linear or logistic. If you are interested in decision tree, which is unstructured, you will do a decision tree or random forest or XGBoost, all those things. But these two are linear by nature. If you want to try non-linear, that's an advanced version. Within ML, you might try neural networks, the basic neural networks like MLP and etc. So every algo has got its own pros and cons. It's very important. Probably you start learn different algos. What is the best algo to use at what best scenarios? That will tell you. Probably you can even tablet. You have in Google cheat sheets of best algo to use in the best scenarios. You can get that. And as you practice, you will understand that. The moment you do an EDA, explore data analysis, you will understand this is the best algo by which you're going to solve it. And the worst case, you have tried with ML, it's not working, there's not of non-linearities. You would ideally bring in DL algo also on the numeric data and try to see whether that can do better job. So it's important you learn the horizontals, depth, the breadth, as well as the depth of this. That's ideal learning, I would say.
Right, sir. Thank you. This should answer the question. Another question we have is that how to understand whether there is a fault in the whatever model we are applying, or is there necessary steps to be taken during the feature engineering? Like, hope you understand.
Yeah. So I mean, that's a very normal, practice. When model doesn't work, we blame model, and I never blame models. None of the algorithm is bad by nature. It's only if you don't give a right data, if you don't know the right algo to apply it, you might get a chunk out. And then as a data scientist, I've seen a lot of data scientists blame that, model is not correct. Model is not good. All models are good. It's just that you don't know what is the right data and right model to be applied. So if you have right data, if model is not doing good, you should go back to your data, because if you don't give a right data to a model, and what model, different algos have a different learning capabilities. If you don't know these two, you would really, end up missing something or missing something. So make sure you know what is the right algorithm to be used and what right data to be used. That's the only guideline I would say. If you start practicing these two, genuinely, please believe that none of the algorithm is bad in nature. They have their own specific purpose or place to use it. If you know where exactly this algorithm to be used, there's nothing to be blamed. Make sure you have a right data. Everything will go good.
Right, great, sir. Great. So thank you for the answer. Another question we have from the attendant is that how important do the intuition works? Like when doing feature engineering, we look for the EDA, right? But
Yes.
sometimes we look for the what are the statistical inferences. But is there anything related to intuition? Sometimes the a statistical inference says that you do not have to select, but intuition says that this is one of the important feature one should consider. So, like, should we go ahead with the statistical inference, or should we also consider the intuition as a data scientist?
I think if you remember my first slide, you will believe, I trust in God, everything else I believe in data. So intuition, I would say it isn't calculated, or I wouldn't say intuition, but if your experience, right? Intuition could be wild. That's a risky place. But experience by domain experience, you're a domain expert. Statistically, there is no relations. For example, I'd give a simple example, like a fraud model, in a banking fraud model. I know the debt to income ratio is very important. But then I'm looking at statistically for a particular bank, I'm trying to correlate the debt to income to fraud. It is not finding statistically very valid, but I will still insist that debt to income should be part of this. Or there's an RBI guideline which says these are the mandatory inputs. Those there is a statistical invalidity, I'll add it. Or there's a business, the business owner, he's already having a rudiment way of doing it, and he believes that this is good. The sample what you collected might not be representing that relations, you might still add it. So I wouldn't say you can work on intuition, but if statistics is not answering, sometime with your domain expertise or a guideline from like a ruling body like RBI or IRA, you can load R from the business inputs, you can load it. You should believe in your intuitions. You should try building new features by your intuitions, but make sure if there is a statistical validity, use it. Or if there's a business can certify that your intuition is right, please go ahead, use it. Otherwise, intuition is wild. I would reframe it as a domain input.
Right, sir. Great. Understood. So another question SR Srinivasan asks, please explain the target leakage check, and it was a specific step in your model, the slide. So what is it?
So target leakage, I was saying, there's a leakage in target. Like for example, I'll use a lot of input variables to predict Y, to predict the target. Which means when I'm trying to take it for production, tomorrow I'm taking for production, the input should be available tomorrow before I run the model, right? It might be so happen that I've got some inputs and they have a very good explainability, but then in tomorrow when I'm trying to take it for production, the data is not available. That's a leakage. That's one typical leakage setup or scenarios where we normally experience. So it's very important. You should also visualize when you build a model, there are 200 features, or let's say there are 20 features you're using it. Are you sure that all 20 features will be available whenever you're trying to predict Y in future also? That's a leakage. If it is not, then you should not even use it, even if you find there's a huge significance. One. Second, without your conscious, you might have built some inputs which is exactly representing Y, the target variable. Like somebody is a fraud or not, and then you are directly taking some inputs directly, saying that, like I was saying, the number of days somebody is going to take to churn. And you are looking at an input which is like dormant, like somebody is using my postpaid for last 20 days, there is no data usage at all, which is a direct relation to a target, but what will happen is you're using some 100 features. This feature will have a very dominant behavior in explaining why. What will happen, this will cannibalize, or this called as a multicollinearity or autocollinearities. These are all some of the leakages you need to be very careful of. It's a very big topic, I would say, the leakage, a target leakage, but a very essential. I would say it is specific step. Always I take care in my model when I build it.
Right, sir. Okay. Another question, Harshil asked that, what are some tools that you use to build ML models and test them? Along with that, are there special tools for creating dashboard visualization tools in particular, or what would you suggest?
Yeah, so we have a lot of, So we have a lot of tools, I would say, starting from anything commercial to now open sources, starting SaaS, IBM, SPSS, and we have SAP. We have a lot of commercial. Oracles have their own tools. So there are a lot of commercial tools. In the open source tools, you have Weka or you have Python. Now, Python community has grown like anything. And the maturity what we have. Initially, when I started my career 20 years before, the functionality in the commercial tools and the open source tools were very high. The gap is very high. People are relying on commercial tools. Now the gap is so low that a lot of companies are totally relying on Python or open source tools. So Apache is the framework. Look at all the Apache tools. That is one. Second, you are in an industry, your employer has a platform like in GCP, Google Cloud Platform, or an Hadoop system, or an AWS. they will have their own tool stacks. The cloud have their own tool stacks. They would want AWS. They'll have an S3 bucket for data storage. They'll have SageMakers. In GCP, we have a Vertex AI. We have BQ, BigQuery. So the cloud platforms also comes with their own tool stacks to do end-to-end data modeling. So you would adopt that. But we also make sure in GCP itself, we built our own Python and we built, models using Python. So most of our team in Verizon, we are using mostly into Python now. That's what we are into now.
Right, sir. Understood. Okay, then we have another question like, what is the difference between the frameworks and Amazon SageMaker that you talked about in the slides?
Okay, interesting question. So SageMaker is a product. Of course, the guidelines will apply to that. So the framework, what we are talking about is tool agnostic. Whatever I talked about as a framework, I applied in SaaS. I worked with SaaS Institute as a SaaS company. I worked with IBM. So most of the commercial tools who has actually built the execution method, I was part of that company. So a framework is common. It's a common framework. It is tool agnostic, whereas Amazon SageMaker is specific. It's a product. So whatever functionalities, what I am talking about, most of the things you would be in a position to do it using SageMaker. But the same framework, you could apply it in IBM Spaces Modeler also. You can apply it in a SaaS eMiner also, in Python also. So framework is more of a guidelines, but SageMaker is a product where you can apply this framework.
Understood. Right, sir. Okay, that should really answer to the question of Mr. S. Thayamal. Another question, Harshil Pandey asked that how often do you go beyond the already created modules, libraries, or algorithms to tweak them so that that satisfy your business needs?
Okay. How often I go beyond? So it depends on the projects. Very traditional project. Let's say I split the product, like we have more than 100 models in our productions. There are 70% of the models are done with the basic modules or libraries or algos which are already available, like very, very traditional or very frequently built models. So simple forecasting models, we have 1,000+ models. Those models, we don't really work on tweaking or doing a lot of R&D, improving it. So it depends on two purposes. One, the severity of the model, how much the model is going to reap as a benefit. If I'm going to use it for a day-to-day, like a call volume prediction, I do it for a daily basis. I don't really need to maintain 99% accuracy there. Even if it is 90%, I'm good with that. I don't need to really tweak something. But something which is financially is going to be too much, too big money for me. And it is like in one-time model, I built it, like a 5G launch, what we do it. I will put all my efforts. I'll do a lot of R&Ds, make sure I tweak it. So it depends on my tweaking of algorithms, depends on how severity that model is going to be and how frequently I'm going to build it. Very frequent model, I will not have the luxury to tweak it. Or the severity, high, paid models, I have to make sure it is at the highest performance possible so that I earn as big as possible. There are a lot of times where even an improvement of 0.1% accuracy could be $1 million for me. So there I obviously put all the efforts, but in other places where even 5% increase, it largely burns me. Even 5% reduction in accuracy, it largely burns me something. For me, I wouldn't mind going with a very traditional one. So the call is basically on my need and the severity and the output what that product then the model is going to generate. But there are places where the basic algorithms are not working. We are very new we are the pioneer in a lot of places. We have a very mature A&D setup in Verizon. So a lot of projects where we are looking at futuristic projects where the current algos or modules or libraries are not working. We do a lot of E&D, even in deep learning, changing layers and updating the layers to make sure the model performs well. But that's, I would say, last top 10% or 15%, not beyond that.
Understood, sir. Right. Since we are beyond the time, let's take the last question and then we can wrap up for the session. So the
Absolutely.
question is like, how important, like you explicitly pointed that things are very important to document the stuff, right? While performing and doing the projects and all. So how important is adding the comments in the processes and the steps? Also, please share like how not following the proper methodology has impacted the project in overall.
Okay, we never ever built a model without comments, without format. There is something called as PEP 8 standard, PEP 8.0 standards. It will tell you exactly how many comments you need to make. If when you give a naming conventions, you should not have only two-letter names. So all those are available. If you go and Google it for PEP8 standards, it will tell you what is the norms to be followed. Every project we built in Python or any coding, typically let's say Python, once the model has been built, we run through PEP8 standard and it will give you a 10-point scale. If the scale is not beyond 7.5, we never take it for production, which means the commenting is very important. And that PEP8 standard run, it will also tell you where and all you missed commenting, where and all you missed the nomenclature, name in nomenclature, everything. It is very important because you build one model. It's not guaranteed that you're going to stick with the model for last 10 years, next 10 years. Somebody else is come and go through this. When there's a need for redevelopment or recalibration, somebody else will come and do it. And if the code is not having a proper comments and everything, it's very difficult for them to learn through that and then go and change it. It's better they'll erase everything and start from scratch. That'll be easier than looking at your code if you don't have a comment. So a very normal industry practice, if there's no comments, if there's no detailed understanding of how this code to be treated, we don't even take it that for productions. And in Verizon, we mandated that every project goes through PEP8 standard, and if the PEP8 standard doesn't tell 7.5 and above, it doesn't get qualified for production.
Right. It's a very informative thing. Thank you, sir. So that's it from the question from my side. That's the question we had. I really thank you for the informative session. And that is really very insightful and learning that today we have learned across what are the proper methodologies and practices one should do while preparing the models in the field of machine learning. Thank you, sir. So
perfect. Thank you. Thanks all. Thanks for your patience. Have a good day. Bye.
Yeah. Thank you, sir.